Hey robot makers, hope you're having a good day so far. So do you want to build your own home automation system using a Raspberry Pi? I'm going to use a Raspberry Pi 4 today and some Python code and something that's called Home Assistant. Then this is the show for you. So we're also going to be briefly looking at the Mqtt automation hat as well, very briefly, but I wanted to sort of show that as well. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let me get over to my keynote and we can get this party started. So yeah, this is all about Home Assistant. And surprisingly, I've actually not used this before. So the goals of today's session, then we're going to have a look at some of the home automation ecosystems very briefly, have a bit of a talk about them. We're going to talk about what Home Assistant is. We're going to have a look at it as well. You can see some of my setup so far. We're also going to look at how to set this up using Docker. This is my much preferred way of installing anything nowadays. That's something that I want to leave on in the background, and we'll talk through why that is too. We'll also look at the Mqtt automation hat Mini, which is the smaller one designed for the Zero, but I've got it on the Raspberry Pi 4. We're also going to have a quick recap about Mqtt, which we've looked at previously, but I thought it was relevant to this. And then we'll look at some Python and automation, which also uses that Mqtt and kind of bridges the gap to Home Assistant. So let's get straight in. So, home automation ecosystem. So I would say there's three big ecosystems. You might decide there's a fourth with Samsung, or maybe is it Smart Things, but really the big players in the market at the moment are Apple HomeKit. I use that one myself, having an iPhone and the whole Apple ecosystem. There's the Amazon, which I don't want to trigger off everyone's Home Assistant with that. They have loads of different things, such as Nest. I think that's now owned by, why is that Google? No, I think that's Google, isn't it? Amazon, they own Ring, I think. So there's quite a few different devices, but they have the majority of smart speakers, or Google Home, which is the third one. I think they're the ones who own Nest, actually. So they have things like the smoke detectors, which is what I've got. They also have the cameras as well, but they have a lot of other devices beside that too. They usually have some kind of smart home assistant, which is like a screen, like a bit like a tablet and a smart speaker, and you can have them various things around your house. The idea is you speak to them and they do various things, and then from that there's also plugging into all the home automation things like lighting, like blinds that can come up and down, locks if you're into that kind of thing. And one of the issues is that each one of these three ecosystems is actually like a walled garden. It's a silo, and they don't talk to each other very nicely between them. Now there are some things like, say, Philips Hue lights. They'll work on all three, but when you're using one ecosystem, it's not really aware of and kind of ignores the other two ecosystems or the rest of the industry. So there's one thing that's going to change very, very shortly. I believe it's this year, later this year, and that's Matter. There's something called Threads and there's something called Matter. And if you go and have a Google about that, it's essentially these three getting together with the rest of the device manufacturers in the industry and agreeing a common communication protocol standards, if you like, so that you can use one on any of these systems and they will all interplay nicely. So that sounds to me like chef kiss, the kind of scenario we want to be in. So that was the kind of official wall garden proprietary ecosystems, and then there's the kind of DIY ecosystems as well. So Node-RED, we've played with that one on this channel quite a few times. I'm a big fan of Node-RED. That came out of an IBM sort of development lab. I think it's a British guy who sort of built the code in the first place. It's really nice, really easy to build, very quick Internet of Things automation type platforms, loads and loads of community support on Node-RED, and it runs in the background on Node, which is the JavaScript sort of backend. Then there's Home Assistant, which we'll be looking at today, which is a really, really great platform. And then there's also Openhab, and I used a flavor of Openhab previously. I think it was called something like HapNode.js. It's kind of the back-end node thing using JavaScript. It was really janky, I found, to work, and I built quite a bit of my early home automation stuff using that. I've got rid of that now, but essentially that had a platform that could integrate with HomeKit, which is what I prefer to use. I think it's called HomeBridge. And then it had its own platform for managing home automation, like not a great dashboard. It was my experience at the time. Maybe things have moved on, but today's all about Home Assistant, so that's what we're going to be looking at. There are many, many others, so if your favorite one isn't listed here, put it in the comment, let me know what it is, and I shall take a look at that one later. So yes, today is all about Home Assistant. So this is a really, really nice platform. So what is it, and what can we do with it? So from their website, they say this is an open source home automation that puts local control and privacy first. So what we were saying before about all these big, the reason these big players in the, my stomach's rumbling there, the reason the big three in the sort of walled garden ecosystems, some of them are interested in your data, like Amazon and Google. Apple has got more of a privacy thing, but they do store your data in the cloud and use the cloud to kind of coordinate things. Home Assistant is very different in that it doesn't need to send anything out to the cloud. Everything can be done on-premise using your own systems, and that data is yours to control. So it's powered by a worldwide community of tinkerers and DIY enthusiasts like myself, and it's perfect to run on Raspberry Pi or local server. So that's exactly what we're going to look at today. And I was looking at that nice screenshot they have on the website, and it's really easy to knock that up using Home Assistant. That isn't some kind of glossy thing that you can't achieve. You can do exactly that. So one of the cool things you can do is you can tighten with your mobile phone if you have the app installed, and that will talk to your local server and send it things like presence information, so you can see where you are and, you know, set up a geofence for certain locations like home, work, things like that, parents, whatever, children, and then you can sort of, as you're traveling between them, it can update and say where you are. And it's got some really nice graphs and things like switching lights on and off. We'll have a play with these lights I've got in the studio, and I'll show you how much easier it is to actually turn them on and off using Home Assistant than it is actually using the app on my computer. So that's very, very quick overview of what they talk about. So if you like what I do, please make sure you like this video, you give me a comment, let me know what home automation system you prefer, which ecosystem you're kind of bought into, and if you've not already subscribed to the channel, make sure you do. That costs you nothing. So yes, the other thing I always do is I go live every single Sunday at 7 o'clock British summertime, or GMT, depending what time of year it is. So if you want to catch live, it's local time to UK, which is usually GMT +1 in summer. Oh, thank you, Marcus. It's got somebody subscribing there. So some of the features that we have on the Home Assistant works with over 1,900 devices, and this is probably an out-of-date number now. I suspect it's probably way over that. You can extend your system using add-ons. It has a companion mobile app, which I've downloaded again for free. There are some powerful automations that you can do in there. I would say there are a little bit of a learning curve on doing the home automations, and we'll have a look at that. And all your smart data stays local, so you are in complete control of where your data goes, and that's, for me, it's quite a big one. And home energy management, they've also got into the solar and car charging thing. You can manage all your data, your home energy management system using this too. And you can see there on the little icon on the little graphic on the right there, all the different sort of sub ecosystems you can plug into. So like the Amazon one, you've got Ecobee, ESP Home, which I know Jeff Geerling is doing some stuff on. I would say look out for that back end of next week. There'll probably be something going on with that. Google Assistant, you've got Google Cast, HomeKit obviously, IKEA Tradfri. They have a really good whole range of home automation things, and they are just that little bit lower in price. So if you want to go out and buy sort of a smart light bulb, you can get one from there, and it's a couple of pounds cheaper than if you'd bought like a Hue one, like considerably. You've got Lutron. You've also got Mqtt, which is what we'll be looking at today. I mentioned Philips Hue before. Plex, that's more of a media server, but that can do some stuff as well. Shelly, Smart Things, Sonos, which is all your nice speakers. I've got some Sonos speakers in the living room. You've got Z-Wave, Z-Wave.js, and Zigbee. Zigbee is the communication kind of protocol between smart light bulbs, so that's how they form their own kind of mesh. It's quite a smart system. So that is all the different features, if you like, of Home Assistant. excuse me, I've been eating pizza for my tea and I'm like full of wind now. So Home Assistant, we're going to actually set this up using Docker today. I hope I'm going to be able to show you this. I've literally got a Raspberry Pi 4 hot off the press. I've just installed the brand new version of Raspberry Pi OS on there, the 64-bit version. I've just downloaded Docker. I probably just need to give it a reboot and then we can install it. And I want to show you just how easy this is using a Docker Compose file. It's one of my favorite features about Docker. We'll also install Portainer, which I love to manage all my Docker instances. And if you want to download the code and play along today with this, I've shared all my code on GitHub. So if you go to github.com/kevinmcaleer/clusteredpi, then you will be able to get a copy of that. So just looking at the chat down there, it's distracted me. Somebody's asking what TFA is. I'm not sure what you're talking about there. So yes, what else? Well, yes, if you want to download that scripts, you can do. They are set up for my system, so you might have to change some of the things. All right, they talk about two-factor authentication. Cool. Okay, so let's have a look at the automation hat. So this is what I've got on my desk over here at the moment. This is the automation hat mini, so it's sort of a smaller version. They do a larger version that's got 3 of these not solenoid relays on there, so it can switch a very large voltage. I've actually not got anything plugged in at the moment to any of the sockets. I don't have anything that requires 12 or 24 volts, so it's quite tricky for me to actually use it and give a demo of it today. But I will come back to that. I just wanted to plug it in because we're doing about home automation today. And I had this sat around for quite some time. And it comes in like a really attractive packaging as well. One of the things I love about Pimoroni is just their attention to detail. If you like, look at the packaging on that. There's it's like just got a really nice look and feel about it. It's sort of a shiny. Anyway, you get the idea. That's what it is. Also, does that UI remind you of anything? When I look at that, I just see Star Trek, like the LCARS, Library Computer Access Retrieval System. So anyway, this has got the same kind of display that you've seen on the Enviro Plus, which I've got next to it. I think it might be the same size one as that. And also, no, it's not the same size as that. It's the same size as the Grow Hat. So a similar kind of form factor that they've used before. So that's the 0.96 inch LCD 160 by 80 pixel display. It has one 24 volt at 2 amp relay, which is can be used normally open or normally closed. If you look on the diagram there, you've got 2 things. You've got the common ground, you've got normally open and normally closed, and that's just like, you know, is the circuit normally open, normally closed. There's quite a lot of language in the description on the website for this thing that assumes you know about home automation and what you're doing at kind of low level. So please don't plug any mains into this. That's the first thing I would say. This is designed for DC, direct current, not AC. So yes, it has 3 12-bit ADCs. These are the A1 and 2 and 3. And they can read in between 0 and 24 volts. And they've got like plus minus 2% accuracy on that. There is another 3 24 tolerant buffered inputs. There, input 1, 2 and 3 there, and you've also got the syncing outputs there, 1, 2 and 3, and they're all 24 volts out as I understand it. Not sure, I couldn't find in the documentation if you could like output 5 volts. I think it's just a straight 24, so you'd have to just take that and, you know, change it, drop it down yourself outside of this device. You've also got the 3.5mm terminal screws throughout there, so you can plug in the wires directly to this and just screw them in. Just be careful when you're doing that you've got a really solid connection and that nothing's going to pull the wire, because you don't want it to be you don't want any sort of dangerous things happening with the voltages. You've also got the breakout compatible pin header on the left hand side there, so if I look at that sort of straight on, you can actually plug in the sort of regular 5-pin breakout garden connector. So it's the same kind of connector that you have on breakout gardens. So for example, I've got a breakout garden adapter here, and it's the same kind of 3 volts. If I can just get that steady, 3 volts, SDA, SCL, and then ground at the very outside. There we go. So the interrupt one tends not to be used. And it comes fully assembled, so you don't have to do anything other than just sort of push it on. I've screwed this on with a couple of screws, just here and here, and I'm using my, I was going to say patented, but I give these things away for free. stands. This is the Pico version of the stand, but I've got quite a few of them. This is the latest version of the Pico stand, which has got the hole for the reset button, and this is the sort of larger big brother of that you can see there, which is designed for the Raspberry Pi 4. You can download them from go to kevsrobots.com. There's a link to the STL files there if you want to grab them. And of course there's a full Python library and documentation to go with this too. So what can we do with this particular board? So all of the inputs and outputs and the relay on the automation hat are 24 volt tolerant and have many low voltage systems in home automation. Also in cars run either 12 or 24. So yeah, think about boats and cars, they all run on 12 or 24 volts. And we could run something like a water pump off this, for example. I was thinking about for the vivarium that we have 2 geckos, actually Alex's geckos, and you need to spray them with water a couple of times a day, and we could have a little pump that sort of sprays and delivers water into there based on some sort of monitoring from this hat. So the Automation Hat Mini is a great way to monitor and control things like that. You can use these buffered inputs to sense and then turn on and off the state of devices, or get more granularity about the exact input, the input voltage with this 12-bit accuracy, which is quite a lot accuracy. And the syncing outputs can sync a total of half an amp, I think that is 500 milliamps across the 3 channels. And the higher current loads you can use for the relay can tolerate up to 2 amps at 24 volts, which is quite a lot, to be honest. And take advantage of the normally open or normally closed size to get the correct failover state. So again, if you don't know what those things mean, this is probably geared for people who do a lot of this kind of stuff with home automation. So I wanted to have another look at MQTT. I actually gave you some bad information on this last time. I call this message queue telemetry transport. It's not message queue. That's a common misunderstanding, and I had that misunderstanding too. So what is MQTT? It's a protocol for passing lightweight messages between things. Originally developed to control and monitor satellites and oil pipelines. So that's what the MQ is. MQ is a device that IBM sell to monitor and control oil pipelines via satellite links. So if you think an oil pipeline could be thousands of miles long, and there might be many different checkpoints and devices just monitoring the flow of oil, making sure there's no leaks, making sure it's flowing correctly. And those little devices need to be able to send information, and the easiest way to do that, but when you're in the middle of a desert or something, you don't need cellular because you'd need a cell tower nearby. It's just used to use a satellite link. So those devices are actually called MQ. If you go to ibm.com and search for MQ, you'll find all about those devices. And that's what MQ stands for. It's not message queue, it's the name of the device that the protocol was originally designed to work with. So another piece of trivia for you there. So MQTT has got a couple of topics. It's not really that complicated. I found this like really straightforward to use. So you've got the idea of a topic, and it's kind of like a file path, and you provide something like, say, home/kitchen/light, and that will help you navigate to that particular device. And the idea is you can build up a tree of these things, so your home could have all your smart home devices. You could have a room as the next level, so you could have maybe upstairs or downstairs as a separate level again. And then at the very end, you could have the device itself. Then you can have the message which is being communicated on that topic, such as maybe it's like a 1 or a 0, or maybe it is some sensor data like temperature or humidity, that kind of thing. And that will be sent on that topic. That's what the phrasing we use. And the way that we send and receive things is using publish and subscribe. So how content is sent and received to MQTT devices. So you publish your data to the MQTT broker. Other devices will subscribe to that topic that's at the top there, and any data that's sent to that broker on that topic will then be sent to anybody that subscribes. And the interesting thing there is the devices that subscribe and the devices that publish might never know about each other. They just know that they are listening to one as they subscribe, and the other one just publishes and doesn't know who's listening. So it's kind of a separation of duty. And then finally, the thing in the middle that does all the work is the broker. So we sometimes call that the Mqtt Server or Mqtt Broker. And that directs traffic between the publisher and subscriber. And it can do some other things as well, such as prioritizing the traffic, filtering messages out, so you can make messages time-based. You could send 3 messages and say only send 1 of them per hour, and it can handle all that kind of stuff. And the quality of service it can manage, should you send one of these messages or any number of them, only one, or exactly one message. So we'll have a look at that in a minute as well. So topic strings, as we just said, are separated by this /. And so if we had robot lab / quad for the robots, and then legs, you could have each individual leg as a separate topic in there. And it's separated by these /, trying to get the mirrored camera thing there. And they enable structure and organization of our messages. And they're really lightweight. You don't have to define them in advance. You just sort of send a message on that, and then it exists for that moment. And anybody that's subscribed to that can see that message. So similar kind of links that we would have, like home/lounge/light, home/kitchen/door. Or you could have wildcards such as home/ and then the pound or hash symbol, depending where you're from. And that means anything beneath that. There's also the plus symbol, which we've not got on here, and that means any level in between. So if we had, for example, /home/plus /door, that would mean any level that's got so home, lounge, or kitchen, anything that's got a door. Give me the messages from those particular topics. So it's kind of like a wildcard for a specific level, whereas the pound sign or hash means everything below that. We can have a look at this in a minute and have a play around with it. So don't worry if that didn't quite sink in there. So for robotics, we would have things like the particular robot that we're talking to, because we might have more than one listening to our MQTT broker. We can have all the different sensors beneath that robot. We could have things like legs. We could have left leg, right leg, as you can see there, or we could have all the different sensors like rangefinder, temperature, voltage, that kind of thing, battery level. And the hash means anything beneath that, send all the messages. We're interested in that. You don't want to be doing too many levels of... you don't want to be doing the hash at a really low level, because you'll basically get every single message. The whole point is that you just try and just filter out the ones that you're interested in. So publishing is how we send messages to the broker. So we need to know the address of the message broker. So on my network, I've got an IP address that I've had for many years now, which is the address of my MQTT broker in my home network. So it's 152. And then some brokers require a username and password. So I was really bad in the early days, and I've sort of put these in the loft now, these devices. There are Sonoff Devices, which if I've got one just to hand here. Sonoff is a software on-off, and a little device by Sonoff. Software on-off is what it stands for. And it's got two sides to it. It's got an input and an output. And in the middle, there is a little Wi-Fi module in there. It's actually an 8266 ESP8266 chip, so that's what it looks like inside. So you can see the mains comes in on that side and then goes out on that side, and then in between you've got this little relay, a bit like the one on the Pimroni home automation hat. And then on the back there, that little chip there is actually an ESP32. No, sorry, ESP8266, not the 32. It's the ESP8266. It can run MicroPython, but when I originally flashed mine, I wrote the code in C using the Arduino editor, and then I put them in the loft, wired in the bathroom mirror and the bathroom fan, and then they're hardwired to connect to my Wi-Fi, so I had to specify a specific Wi-Fi SID and password, and then they look to that 152 broker address to connect and listened to any messages. And they can also send messages, but I don't think they actually do anything like that. They just listen to a 1 or a 0 on the fan or the mirror. We can have a play with that too. So some brokers require that username and password. When I wrote that code, I didn't do that. I should really go back and address that and provide a username and password for security. A unique client ID will help identify where messages are coming from, and you can actually pass that in the message, in the payload as well, if you want to sort of help identify where things are coming from. And the client device is subscribed to the topic and listen for messages. So that's how we publish things. Let's move to the next one. So think of it like a magazine subscription. You send off your application to receive subscriptions to your newsagent. Whenever a new magazine comes out, you get a copy, they send it to you. And you might not have a relationship, therefore, with the people who publish that magazine. You just get the copy of the message of the magazine when it arrives. So the agent handles the distribution of the magazines to the subscribers. The publisher sends the copy of the magazine to the newsagents of the subscribers. And the publisher needs to know which agents to send the copies to. And that's what the broker actually does in the middle. So what does a message look like? What's the anatomy of a message? So we have the payload. The payload, this is the content. This can be in many formats. It can be a text string. It can be a number, Boolean, binary data. It can be all different things. JSON strings as well. The topic is the path to send the message to the broker. So we usually have a message and a topic. We need the broker address, which is the server address, and the client name who sent the message. You can leave that blank and it will just default a name, I believe. But we need to do that when we create some code in Python later on. We'll need all those 4 things to send messages. So the broker itself receives all the messages. It can filter them out, like I said. It can send messages to topic subscribers, and messages are not stored. So if you miss it, it's gone. Now, there is an exception to that, and we'll look at that in a minute. It's called retain, and it helps us build more robust systems. So some tips and tricks to do with MQTT. These are some things that I recently discovered, and I was like, yes, this makes a lot of sense now. So never use a forward slash. So if you do /home/, it creates loads of unnecessary messages. It's best not to have that forward slash, just have home/, not /home/. So never use spaces in topics. Always have like an underscore, or just, I would say, just use lowercase is probably best as well. Use really short and concise topic names. So home is a great one, for example. The name of a room is great as well. Only use ASCII characters. ASCII is that American Standard Code for Information Interchange. It's like the 256 characters from the old days when people used to use things like DOS and some Unixes as well. Nowadays it's all Unicode, and you've got 2 bytes for every single character, and you can have lots of different languages represented by that. But this is like in the old days. So if you want to use ASCII characters, and that's like lowercase, uppercase letters, and numbers 0 to 9, and you can have some other characters as well, but it's probably best to avoid those things like dollars and underscores. And no, underscores is okay. Dollars I think you need to avoid because that's got a special meaning within MQTT, and things like @ symbols, pound signs, they all have special meanings, so don't use any of those. Embed the client ID into the topic is a good idea as well. It helps specify where the message is going to as a specific device, unless you don't want it to do that and you want it to go to many devices. But it's quite good to embed the actual client ID, makes it more specific. Don't subscribe to just the pound, the hash. That gives you every single message. We're going to try that in a minute to show you exactly what that looks like. And use specific topics, not general ones. So use like home/robotlab/temperature. I've got a space in there. Or no, not actually. That's a separate one. Or home/robotlab/humidity. So have specific paths. I thought that was all one word for a minute. So there's a few tips and tricks. And I mentioned about not storing messages. So the retain flag is a special thing you can put on the when you I think it's when you subscribe or when you send a message, you can flag this. So the retain flag defines whether the message is saved by the broker as a last known good value for a specific topic. So imagine it's like in its dying breath, it sends out a message. The broker can actually save that, and then if that client then is able to reconnect, it can read what that last value was and then see whether that's still valid or not, whether it needs to send another message to say, no, I've changed. So imagine you've got, like I have in the loft, a fan. If there's like a power cut and then the power comes back on, the MQTT broker might think that the fan is still on where it's actually off. So we can see what the previous state of that was because it's got this retain flag. So it's kind of like a toggle, but with an actual message. So that's what retain does. So when the client subscribes to a topic, they receive the last message that was retained on that topic. And that helps devices connect with that disconnect and reconnect be more robust. So if there's a disconnection, it can carry on. Again, this is designed for pipelines, which are thousands of miles long in a desert somewhere, sending messages that are very expensive to us via a satellite link, and you want to try and reduce the number of messages that you need to send there. So that's what that helps with. So quality of service, this is something you can include on each message as well to say how important it is. And so quality of service, or QoS, is the level, the QoS level is an agreement between the sender of a message and the receiver of a message that defines the guarantee of a delivery for a specific message. So there are 3 levels. You can send at most 1 message. You can send at least 1 message, or you can exactly once, which is level 2. And think about why this is. If you think about sending postcards, for example, in the post, does that translate to many other cultures? In Britain, we send like postcards when we're on holiday to people. It's like a really old-fashioned thing, a bit like a telegram. So you scribble down your thing, you send it off, and you don't really know if it's going to get there or not. You just hope it does. So if you send off a bunch of postcards, you don't really care how many the other person gets as long as they get one. So at most, they're going to get 1 message on QoS level 0. QoS level 1, at least once, means that they'll get the message at least once, but they might get it multiple times. And then you would have to deal with what happens if there's multiple messages coming through. And then the exactly once means there's a bit more talking that goes on between the broker and the client to say, here is a message, and it says, yes, I've got that message. And it says, which message have you got? I've got this message. Right, okay, we've agreed you've got that message exactly once. So there's a lot more backwards and forwards. So it's not quite like sending a telegram or a postcard. That's like some kind of written correspondence, track delivery with guarantees of signatures and everything. So that's kind of what's going on there. So let's have a demo of Home Assistant. We've talked about it long enough. Let's have a look at it. So what I'm going to do, I'm going to try and spin up a copy of Home Assistant on a Raspberry Pi that I have. So I'm just going to grab over here and get my Raspberry Pi on screen, and we can have a look at what I've been doing here. So just before the show, I was installing Raspberry Pi OS. So this is a fresh install of Raspberry Pi OS. I've installed Docker, but I've not rebooted it yet. I think I need to give this a reboot before we do anything else on it. And I've also installed Ansible, which I use to set up a lot of my servers. So what I typically do is I'll give the device some random name. I don't really care. These are not pets. These are just cattle. These are just a number of Raspberry Pis, and I have all the configuration all in code, so I can very quickly tear down and build up another machine, and I don't really care what it is, what it had on it previously. I just know that this will work. So what I've done is I've downloaded the clustered Pi from GitHub, which is my code repository that has all the different Docker configuration files and also all the Ansible files. Ansible is like an automation, not home automation, but like computer automation, so you can automate scripts. So if you had, like, say 40 Raspberry Pis, then you could have a script that connects to all of them, does like a sudo apt update on every single one of them, so they're always up to date. You could have something like that, for example. Okay, so what I'm going to do on this Raspberry Pi is I'm just going to reboot this very quickly. I'm just connecting over VNC, and I've also got next to me, so this is the actual computer we're using now. You can just see the little lights there. And I actually have, if I just point my other camera, which is this one, I have a little screen on the pin board there. And when it's rebooted, it will actually see that they're connected to this over here. So I'm not sure why that's not showing up just yet. It's taking it a bit of a while to shut down. I can see that it's still flashing its little LEDs there. But if I just leave that sort of pointing up there, this is like really crude. There we go. I can see that it's done now. There we go. So I've also got the keyboard and mouse down here as well. There we go. You can see my leg there. We have the keyboard and mouse as well connected to this, so I can do any setup that I need. But the easiest way to see it is actually on this VNC connection that I have. It's telling me there's a load of updates available, but I'm not too bothered about that. So the first thing I want to do is just check out, does Docker actually work? That's a good sign. If it's thinking about it, that means it's just firing it up. Awesome. And what I've got, like I said, I've done a git clone of Clustered Pi. The link is, did I put that in the show notes? I can't remember. Essentially what you need to do there, if I just move me out of this away for a second. If I do, I think I've got git installed on here, git clone, https www.github.com/Kevin McAleer /clustered pi. Like so, it'll download the latest version of Clustered Pi, which is all my scripts that I use for running the Clustered Pi server behind me, which is that little thing just there. And also the website clusteredpi.com is all in there too. But the things we're interested in are the let's just go into it. So cd Clustered Pi. I've set up a virtual environment, venv, and you do that by doing python python -m venv, and what that will do is that will set up a virtual environment. So I've got a question there. Can you dabble with Raspberry Pi 3? Absolutely, yes. It'll work okay on a Raspberry Pi 3 as well. I've just got a Raspberry Pi 4, so I'm making use of that, but it will work fine on a Raspberry Pi 3 as I understand it. I don't know how many instances you can run, because a Raspberry Pi 3 has only got 1 gig of RAM, whereas Raspberry Pi 4 you can have up to 8 gigs currently. I think this one I've got is 4 gig, so a 2 gig or a 4 gig. Okay, so what I'm going to do now then, I'm going to load that virtual environment just by doing source, and then it's venv bin and activate. That's the path to actually make this. And what else do we have now? So Neversync Make says, I've got a Raspberry Pi 4. That's a flex right there. I've got a number of Raspberry Pi 4s. Let's not go on about that too much. So yeah, I noticed yesterday Pimoroni had a few on their website. I don't think it was showing up on Raspberry Pi Locator, so I managed to bag myself another Raspberry Pi 4. That's coming in the post tomorrow. So what else am I going to do? So we've gone in there now. What I want to do as well is go into, so I've got a number of playbooks. So these playbooks, so there's one there for Portainer, for example. I've got one for Node-RED. I've got one for Grafana, Docker, and so on. We've already got Docker installed, so that's fine. But we actually want to, we want to go into the stacks folder. Stacks are all the Docker compose files. So if I go into Portainer, for example, and I just do Docker compose and then up. I'm not going to do /d. We're just going to do compose up. That will bring up the container. So a container is all the files that we need to run a particular application. So this is the first time that I've actually run the Portainer one, so it's got to download all the image files. You don't have to worry about where they are. It knows how to do that because it's clever. All I needed to do in the Docker compose file is just tell it what the name of the image is. And there's also some other settings in there. We can have a look. It's a really small YAML file. And they always have to be called docker-compose.yaml. So once it's downloaded that, it will then spin up the server on this particular machine, and we'll see all the messages that appear as well, because I've not done space-d for disconnect, which means just run it and then disconnect, and it'll run in the background. So it's still just extracting. There we go, pull complete. It's now checking to see if everything's right. It's creating Portainer, and it's going to then, you'll see all the other status messages. And because it's the first time we've run, we would have to connect to this and then set up Portainer. So we can do that. So it says there it's on port 443. So if I just come out of here and go into a different web browser, I'll show you my screen in a second. Let me just get, I think it's 89.9443, and I just need to do HTTP. Let's try. I'll show you the screen in a second. I just want to make sure I've got it set up correctly first. There we go. Right. Okay, so I've just loaded up a web browser. I've typed in the IP address of the Raspberry Pi, and then I've used the port number 9443, which is the Portainer port number. So I'm just going to type in a password here. So let me just think of a password. and it needs to be 12 long, so let's go for that. Create the user. Okay, so now we've got, it's talked about setup environments, but the local environment for Docker is already there, the local one. So we can go in here, we can have a look at the containers, and we can see Portainer is already running, which is the container we're using right now. And I want to spin up Home Assistant. So let's get back over to the Raspberry Pi. I'm going to actually press Control-C and stop that container. And then I'm going to do -D for Docker Compose up. And it started that Portainer, so Portainer is still running in the background now, and we can use that to look at our Docker instances. Right, so I'm going to come out of that Portainer folder. Actually, I'll just show you what the YAML file looks like, just very briefly. So you can see there, it's like a really small file, and all we need to define there is the service name, the version of the format that we're using, which is 3, the name of the service. You can type anything you like there. The container name is called Portainer. That's just a nice friendly name that we can call the container we're using. The image, that's the important bit. That tells it where to download the image from that we're interested in. And then the volume, this is a specific one. It's a bit like a drive. You can connect a virtual drive to your Docker instance. And this one, the var run docker.sock, is a specific thing that we need to connect so that we can manage all the Docker instances. And then there's a restart policy. So unless we stop it, it'll keep rebooting it. Privilege true means run it as like the sudo user. And then what ports do we want it to access? So 8000 and 9443. And it just kind of maps the inside port to the outside port because you can change them. Right, so we're just going to back up a folder, and we're now going to go into Home Assistant. And if I just do the same there and have a look at what's inside this this Docker file, we can see there, so version 3, services is Home Assistant, the container name is Home Assistant, the image is that there, which is the Home Assistant Docker image. We want the stable version. The volumes that we want to connect, so we want to connect the clustered Pi Home Assistant config folder, which is all the configuration. There's like a configuration.yaml that you need for Home Assistant. So all my setup is in there. And that means if I tear this down and install it on another one, I've got the same YAML configuration file, so it'll just carry on working as we like. We have the local time so that it's got the correct time zone information. Again, the restart policy is unless we stop it, it'll keep restarting. It's running as a sudo user. And then I've also defined 2 extra things. So I've created an external network that's called a MyMac VLAN. And so I'll have to make sure we create that in Docker as well. And we've also got the IP address that we want this to present itself as on the network. So I'm not going to run this one myself because if I run this, maybe I need to change that. I'll tell you what I will do is I will just edit this file, my local version of it, and get rid of some bits from there because we don't need all of that. But I do want to run it just to show you how easy it is to install. So if I basically just get rid of all this last bit of stuff here, I'm sure there's a quicker way of for doing this, but if I just get rid of these lines here, it won't use a specific IP address. I use the IP address of the Raspberry Pi, which is 89 on this one. There we go. So if I just save that, and if I do now Docker compose up-d, it will download all the things it needs for that particular Docker thing. You can see there's quite a few components to it, and then it will start working in the background. And the IP address will be the IP address of this particular Raspberry Pi that I'm using, which I think is 89. Yep, 89. So it's going to take a couple of seconds. So while it's doing that, I'm going to show you my setup, but that's how we can install it using Docker. And the reason you want to do that is because it means your machine isn't tied, your configuration isn't tied to a specific machine. You can very easily install this just by using some scripts, and it's repeatable. So if you forget 9 months from now, you just know you need to run that Docker compose up and it'll start working. So it's nearly done actually. Let's just let that complete. I just want to show you the sort of onboarding part because that's quite cool. You just type a username and password in, and then it'll detect all the smart home devices on your network. Now some of them will require like a connection. So Philips Hue, there's like a box and you need to press a button on it to sort of say I'm authenticating this. By pressing the button, you're kind of giving it a shared key for a certain number of seconds, like 2 minutes or something, and then after that it'll stop allowing things to discover it. So that's taken a little bit longer than I thought. So what I'm going to do, I'm going to come back to over here, and then I'm going to go to my Home Assistant. So I've got a number of cameras you can see there. So let's have a look at Fish Cam. There we go. We've got the fish camera. I can hear the sounds as well. We might see some fish go past in a second. And what's really cool is these are the Nest cameras, and you can see there it even says Nest in the corner. And it's because Home Assistant can play nicely with HomeKit. I can actually now get those cameras on my phone, not using the Nest app, but using the HomeKit. There you go. We've got some fish going past there. They don't know they're famous on the internet. I've got a number of different dashboards. So Home Assistant allows you to create as many dashboards as you like, and these are kind of mobile friendly. So if I shrunk this right down, those tiles would sort of stack themselves nicely. You can see there, if I just move out the way, you can see there I've got some things like the lights. So if I turn off this light here, you can see my face goes dim. I just move that out of the way there. I'm just clicking that button there. As I click it, my face is going dim. And there's another one there for overhead light, which is the overhead next to me. You can just about see my shoulder going and the background going slightly darker there. So this is really cool. It's detected these Elgato key lights and it presents them. So if we go to the settings, which is this cog thing here, we go to devices and services. We can see all the different integrations that it can do on my home network. It's found all these different things. So we've got HomePods, we've got Spotify, Philips Hue lights, Apple TV, there's quite a few of them. Philips Hue, I've not configured those yet. We've got Samsung, I think that's a smart TV. There's a Samsung, I think that's another TV actually. And we've got Google Cast, we've got a printer which is next to me. We've got the Raspberry Pi printer that I created using a thermal printer and shared with AirPrint. It's detected that. We've got the 2 Elgato key lights. We've got my HomeKit cameras, which we can now see. We've got an if then that hook, so I can hook in. Somebody could send me an email or tweet something, and then this can pick it up and do various automations based on that. We've got the Mel Cloud, which is my air conditioner, which is Wi-Fi connected. We've got something that's called Home Weather, which basically just defines where your location is and then can get weather reports for that. And I've also connected my mobile phone using the Home Assistant app. So it can grab various different things from that, such as my presence location, where I physically am, and so on. We've got my Mqtt server. So that took me all of Saturday to set up, and it was just a stupid mistake to do with networks in Docker, because essentially I had an internal Docker thing that didn't have an external IP address, and I was trying to connect my my Mqtt service here to that broker, and it couldn't see it. So I had to basically just add in that 150, I think it was, IP address. We've got the Mac Home Nest, all the different cameras and things we have there, and smoke detectors and thermostats. We've got the Sonoff, which is the speakers. I've got a couple of those. And Sun is just another standard one from Home Assistant, which is like when does the sun rise and when does the sun fall, because you can base triggered automations based on that. So they're all the integrations. You can add more, and there are loads of them, absolutely loads of them. So if there's a specific one you want to know, does it do that, we can have a look through that if you're in the live chat. I've set up the Mqtt, that was the one I had to find, and there's the IP address of my Mqtt broker. And what else do we need to look at there? So you've got things like devices, so they're the actual devices and device models and so on. Entities is similar to devices, but I think there's a link between the two. And then helpers is you can create things like a button. So if you want to create some code, which we will do in a minute, in Python to switch a fan on and off, you would just create a connection within here. So if we go to, I think it's that one. Nope, it's not that one. That basically is just a fan on off. Do we have any advanced settings on that? No, not really. So what else have we got down here? So we've got a number of other different things. So we've got the Home Assistant main page, the overview, which is sort of automatically set up for you. But you can see there's a little little camera there. Here I am. If I wave, there's a tiny little bit of a delay because it is running through about 3 different systems, but there you go. You can see me there. Alex is in Sheffield today, so she's not sat on the chair there. What else we got? Is that a dead ladybug on the top of the cabinet there? We have energy. So if you've got like home energy from your solar panels, you can plug all that information in there. You've got things like maps. We have a logbook of all the different transactions that have happened, all the different history of things. So devices switching on and off, you can track all that information. All the different media. Developer tools helps you do things like configure your YAML configuration file. You do have to get sort of down in the weeds sometimes for various things. And then we've got the settings thing, which is where you do most of the setup of the home automation. So if you want to set up an automation, you come into automations, you click on the create automation button. You can either use an existing blueprint, or you can go for an empty automation and then just define yourself. So what's going to trigger it? Is it like a geolocation? Is it an MQTT thing? If it is, what's the topic for that? So you could have like home / bathroom / I don't know, fan, something like that. And if it's a 1, then that's what we want the trigger to be. And then we can define actions based on that. We can also define in here scenes, scripts and blueprints as well. So there's a number of things there that we can set up. And the notifications is just things like, so for example, on here, that's HomeKit pairing thing for that bridge. I think that's something I did before. And you basically just go into your HomeKit app on your phone, scan that code, and then it will detect it. It won't work for you if you're trying to screen grab that. It's only on this local area network. And then if there's additional devices, it'll tell you that it's found additional things, and then you come in here, click on the configure button, and so on. So like I said, on that Philips Hue one, you have to press that button, and then all the lights and all the connected things within that hub will then appear in here. Okay, so that is Home Assistant, how you can use it. Let me have a look and see if the Raspberry Pi has finished doing its thing. So it has. So if we now go to, so if I just go back to that web browser and into Portainer and just refresh that, we should see now that there's let me just go back to the home. Maybe I just because I'd rebooted it, I took down the Docker instance and then put it back up. We just need to log back in here, like that. I can see now it says we've got 2 containers running. So let's have a look at the 2 containers. So we've got Home Assistant there, and we've also got Portainer. And the reason I love Portainer is because you can look at things like the log files. You can see, is there any messages there? Everything looks good. You can also jump into that, the console of that particular thing. So I think you just need to drop down to SH and then do connect. And then you can do things like have a poke around, have a look at like the Home Assistant configuration.yaml, things like that. There's not very much going on in there at the moment. Right, so what we can now do, we can basically just take that IP address, and then the Home Assistant one is 8123. So if I plug in this here and do 8123, and then let's do, is it HTTPS or is it HTTP? Let's try that. I think that's right. So why is that not letting me see it? Have I not exposed that port in Portainer? Let's have a look in Docker and to see if that port is actually being exposed, and it's not. That's the problem there. So if I go into here, have a look at the setup. There's a lot of stuff going on there. Essentially what I need to do is go back to the Raspberry Pi and just edit that file so that it exposes that port. So if I just do sudo, I don't even need to do sudo, I'll do it anyway just to make sure it works. Nano, and then the Docker compose. And then what I need to do down here is just add an extra line that says port, and then it's 8123 to 8123, like that. Let's save that, exit. And then let's, instead of doing Docker up, we can now do Docker down. And what that will do, if I go back over to here in our Portainer and look at that container that's running, This Home Assistant one, in a second you'll see it'll be offline. And what I'm trying to do is add in, where it's got published ports, I need to publish that 8123. That's what was missing from there. So let's just check what's going on there. See if that's brought it down. Let's do... it's saying that the configuration is wrong in that file, so let's just edit that again. So instead of ports, it should be ports with an S, because you can do multiple ones. Let's do that. Let's try Docker down again. So ports contains an invalid type. Let me just edit that. Do I not need to put the speech marks around it? Let's try that. Oh, it should be an array. Okay, so what we need to do there is just put that on a new line with a dash. I'll get there in a second. Like that. Okay. Because you can have more than one set of ports. That should work now. Yep, there we go. Docker down. So that's now stopping that particular Docker instance. We go back over here and refresh. We'll see that this will change to stopped in a second. There we go. So it's now disappeared. It's now just an image that's not being used, which is that one there. So if I now go back over to the Raspberry Pi and then do docker up -d, it'll spin up that that thing with the right port this time. So if I just go back over to Portainer, have a look at what containers are running, there it is, and we've now got that port 123.8123 actually showing. So if I reload that, there you go, we've got Home Assistant. So I need to give this a name for the particular home. So I might call this Mqtt, for example. Oh no, that's my name. That's my name. Let's do Kevin. So the username is going to be Kevin, and then let's set up a password. Why it's not decided to match those. There we go. Create the account, and it's just asking for some things there. So what do you want to call your home? I might call this one Mac Home. You can type in whether you want Celsius or Imperial, what currency you want. So I might want GBP, for example. There we go, GBP. And then next. And then you can decide whether you want to send any data back to the people that write Home Assistant. There are some people who do this for free, but there's also a company, can't remember the name of it now, but they actually write the app for this, and you can pay a small fee to be able to remotely use this when you're not at home. And they'll do that thing where it kind of bridges together, but you can basically just decide, I don't want to send them anything, I just want it to be my own home, my own private local home automation. So devices and services are represented in Home Assistant as integrations. You can set them up now or do that later. I'm going to do that later. And then we've got a nice fresh instance of Home Assistant using Docker. So we can do things like go to those devices and services. We can then add integrations. So if I wanted to add all my Philips Hue, I can go in there, click that, and it'll add in which of the Hue servers. I could add all three of them in there, and then if I press the button, I can't remember which one I've got in. I've got three of them basically, one in the loft, one in the living room, and one down here, because I've got so many Hue lights I needed a couple of extra ones. So there you go, and then you can then do things like edit the dashboards. It always talks about, do you want to take control of a dashboard, because it will automatically generate a dashboard based on the devices that are there, or you can create your own dashboard. So you can go into the this screen, I think, and create extra dashboards somewhere. I can't remember where that is now. Well, there, dashboards, and you can basically just create a new dashboard. So let's call this one like new dashboard. And then you can decide what kind of icon you want it to have. So if I want like robot, I could have that little robot there. That one, there we go. Create that. And I've now got my new dashboard, and I can edit that to my heart's content. So if I edit that dashboard, I can take control of this. I can add a new card. My favorite card, I think, is Glance. And this one, you can sort of add extra things to it. So you add the entities that you're interested in, like me. So there I am. You can add another entity, such as the home. I've only got 3 on this one, so I'm just going to add all 3. And let's save that. And then that just shows there, and you can just put that at the top. Once you click done, that's what your dashboard looks like. So if I was to go on my phone and connect to this, this is what I would see. And you can move that out of the way as well. So if you've got presence of information, you've got more than one person sending their presence, their location data to Home Assistant, you'll see other people there and you'll get an indication of where they are depending on the geo fences that you've set up. So if I go to map, so I'm not in Amsterdam, but it doesn't know where I am because I've not sent it any information. But basically I can just grow or shrink or add new zones. So if I add a new zone, I can say like this is the home zone. So I can just type in home as the name of the zone. If I had, I don't know, let's go over here. Let's add a new zone. So say I worked, I don't know, over there. I could call this one work, add that. And then if I move between those different zones, if I went from my home zone into my work zone, and you could make that whatever you want, then your presence information would say, you know, Kevin home or Kevin work based on those geofences. So that's pretty cool. You can do all kinds of clever stuff with that. One of the projects I was thinking about when I saw this was, you know, in Harry Potter when they have that clock and it shows you all the different locations of the Deasleys or whatever they're called, Deasleys, them people, the ones with the ginger hair. I liked that. I want to make one of them, and you could use presence information from Home Assistant, sending that to an MQTT broker to do exactly that. Right, so let's get back over to our keynote and let's have a look what we've got next. So if you want to join me on Discord, you can hop over to action.smilesfan.com/join-discord, and we've got a growing community there of people who really like robots, Raspberry Pis and programming. So join if you want to do that. So I also said we would have a quick look at Python and MQTT and create some code to send to the MQTT broker so that we can then integrate it with Home Assistant. So what I'm going to do, I'm going to grab Visual Studio. I'm going to go over to Visual Studio here, and I'm going to load up the right ones. This is playing around with the Docker contain files, but I actually don't want that one. I want the demo, which is this one here. So here's some code I created earlier. I just want to very quickly show you the code, and then we can run an example. So what I've done is I've created a virtual environment, which is called VENV. And again, to create a virtual environment, what you need to do, if I just come down to a little terminal here, and if I type in Python, you don't normally have to type Python 3, but I'm on a Mac, and for some reason it forgets that it's got a Python installed unless I put the 3. If you do -m, which is like the module thing, and then you type VENV, which is like create a virtual environment, and then you give your virtual environment a name. So if I call this one Kev's Amazing Virtual Environment, and then press return, it'll basically just grab all the files it needs from Python and create a new virtual environment. Look what's happened down here. Visual Studio Code has detected that I have a new virtual environment. Would I like to select this? And down here, instead of it being VENV, it'll be Kev's Amazing Virtual Environment. I can actually change that to be the workspace which I created for this particular thing. And then what I normally do when I want to install things like, if I do pip install, let's go back over to that other one I've just created actually. Let's go back over to Kev's Amazing Virtual Environment. So at the moment, if I do pip and then freeze, you'll see that I've only got one thing installed there, parho-mqtt. If I wanted to install that in this new virtual environment, I do, and I can see there that I'm not actually in the correct one there. So if I do source deactivate, source, I think it's just deactivate, sorry. I've basically chosen one virtual environment in Visual Studio, and then in this terminal it has another virtual environment. So if I do source and then Kev's Amazing Virtual Environment bin and then activate, that will activate that environment in the in Python. And then if I do pip freeze now, you'll see that I've actually not got anything installed here, and I need that parho-mqtt installing because that's the library that allows us to connect to MQTT server. So I need to do pip install parho-mqtt. And what it will do is it'll grab that off the web, install it into this virtual environment. So if I now do pip freeze, I'll now see that I've got that installed. So as a shortcut, if you've got many things installed in your virtual environment and you want to be able to create a new one without having to remember what you've installed, you can basically do pip freeze and pipe that into a file. And the convention is you pipe that into something that's called requirements.txt. So if I do pip install -r and then the name of my requirements.txt, which is a requirements.txt, that file contains all the things you need for this code to work. So that means somebody all that they need to do is create a new virtual environment, do pip install -r requirements.txt, and then it'll be everything I've set up in here. So that's the first thing we need to know. And then that means we can then do import parhode mqtt .client as mqtt. So that is a shortcut to that path there. We're also importing time and the sleep function of time. And then we need to set up a couple of things. Remember when we looked at that slide about MQTT, and we always need those 4 things. We need a broker ID, the broker port, a topic ID, and the device ID. So there's my IP for my broker. The port is always 1883 unless you specifically change that. And then the device ID is just a device ID for this device that you want to create. So I'm just calling this fan1. We then need a topic, so I'm using home/bathroom/ and then the device ID, which is fan01. And then the status topic is something I was playing around with. So in Home Assistant, when you install the MQTT broker, if you send a message to that, you can send a get state, set state, or just the status of that device, which is kind of the same as a get state. I don't really know why they've separated that out. So I basically just created a status topic called /state, which should be appended to the end of that device ID. We then need to create something called a callback. So this is a bit of an ugly thing, I think, but essentially you can create a function, and then you can pass that function to whenever a message is received because you're subscribing to a topic, run this function. And that will happen in the background. So that's what this function is all about. So we need a client, we need user data, and we need message. And this function is called whenever a message is received on the status topic. I've just called it status callback. So we set the status message to be nothing to begin with. We then say, and I'm using the F string, which we talked about last time on advanced Python, but it essentially means you can use these curly brackets to include code within a string and make it read a bit easier. So print the message, message payload.decode. So message payload, remember we said we can have all different types of data within our payload. We can have text, numbers, strings, JSON, objects, all that. We're basically just assuming that this is regular text, and therefore we want to decode it as a UTF-8, which is binary bytecode, binary Unicode. That's the word I'm looking for, Unicode. Turn it from Unicode into like ASCII. The user data is whatever is in that user data, and then whatever the message.topic is whatever is sent in that message.topic. Message.payload and message.topic are both inside message. Message is like a dictionary or a list. Then we want to say topic equals message.topics and then split it by the /. And then what we want to do is get the very last bit of the topic. So if you do -1, it'll get the last thing in your list. And so the last topic is the state. And then we're basically just going to set the status message to whatever the device ID is, which is fan01, is OK. And we're going to publish that. So what this will do is if we send a message to the state topic, it will send back the message fan01 is OK. It'll also print out to the terminal, and it'll return that as well. So then the last bits that we need to do, that's quite a long-winded way of just saying it can do stuff when you send it a message. So we want to create the node, so I'm creating fan as an MQTT client. So MQTT is from that Parho thing that we brought in before. We then want to connect it, so we're going to connect it to the broker ID and the broker port, which is, you can see there, Visual Studio is helping me there, so it's 188, and the broker IP is 192.168.1.152. And then the message is status callback, that function that we created. So we're passing that on without any brackets, but we're actually passing in that whole thing. Then we need to do loop_start. And this basically just says, go and do whatever you need to do to start listening to messages. And we want to subscribe to the status topic. So when anybody sends a message to that status topic, we want to react to that. And we also want to send a birthing message. This is another thing which Home Assistant looks for. So if you have an MQTT device, when it's born, when it's first connected, you send a message to the birthing message topic. So I basically just say the fan 01 is ready. Then I've just got a message saying press Ctrl+C to quit, and then I've got a loop that says while true, so I'll repeat forever, or if the keyboard interrupt, if somebody press Ctrl+C, then quit. And look, it does nothing. It just waits for half a second and then goes round again. So why is it waiting without doing anything? Well, because we did this fan.loop_start, that kind of loads up in the background the code that we need to listen to messages. Okay, so let's run this code. So if I go over to here and just click run, you'll see there it says press Ctrl+C to quit. Now if I load up on, let's go over to my Node-RED server. Let's go over here and type in, I think we're on, there we go, 1880. This is also in Docker. And if I go over to bathroom fan, and the topic that's in here is, that's the actual bathroom fan. We don't want that one. Let's try and change that to the one that we've just created. So what the thing we created was home slash, I think it was bathroom slash fan 01, like that. And we're going to send the message, the payload is just 1, which is like a message of 1. Right, so if I click that, oh, I need to deploy it first. So if I click that, what will happen is we go back over to Visual Studio, we should start to see a message be displayed there if we type it on, right, so home bathroom and then fan 01 slash state. Right, so I need to go back over to Node-RED and let's just change that, that node to include slash state, like that. Publish that, click it again, click deploy, and we still haven't got anything showing through. So what am I doing wrong there? So we just check on that. So topic, let's have a look at status topic. So home bathroom fan 01 state, and what are we waiting for in there? Status message. If the topic is that, return that message. Okay. So let me just check I've got everything correct there. So we need to be definitely on home bathroom fan 01 slash state. So let's go back over to Node-RED. Let's double check on there. Home bathroom state 01 state. Doesn't matter what the message is in there. What am I doing wrong there? What am I doing wrong there? So what we can do, we can have a look at all topics. Remember when I said you should never subscribe to just the hash, the pound, which means subscribe to every single message in there. I've actually got that on here. And look at all the different things I've got. I've got my weather station, all the hue sensors, the grow hat, the environment hat, subscriber counts, the bathroom fan thing, which is what we're playing with here. If I go to the debug, you'll start to see all the messages come through. So if I just clear that out, look at all the messages that are coming through there. You can see all the different data from the weather station, from the environment plus sensor, all the oxidization stuff, the temperature from all various different nodes in the loft and in the hall. So these are all flying through. If I've got a 3D printer on, more messages will come through that as well. So you're getting all the messages from all the different devices, which is just like loads. That's why you don't really want to subscribe to that. I've got a really like small number of messages being sent. So let me just try and debug this a bit more, just understand what's going on. So that's publishing it to, so it's publishing it to that there. That was what I was doing wrong. So I was sending a message, but then actually not sending it to the correct topic there. So if I just change that to home slash bathroom slash and then it was fan01 state. And then you can see there we can do the retain thing if we wanted, or the quality of service. We could set that on 2 if we wanted to. Excuse me. And if we do deploy and then we click that now, let's see, do we get the message? Yes, there we go. Status message, fan01 is okay. So our code has reacted to that message that we fired via Node-RED. I've also got another app on my phone which is called Mqtt Analyzer, and we can do the same thing there, leaving that open. So if I go to the Mqtt Analyzer, I go to send, and I'm just going to type, let's get my phone on screen here. So if I type in home /bathroom /fan01 /state, and you can choose whatever you like on these things. I'm just going to send 1, and then I publish that. You can see there the message was 1, that's the topic, and it's returning the message is okay. So if I go over to home, let's have a look and see if we've got any. Is it that one? Bathroom fan01 state, and I can see there the state message was 1. That's what we actually sent to it from here, and the fan01 message is actually present on another topic, which is just the regular fan01. So what we could also do, if I go over to back over to Node-RED, and let us add in an extra MQTT in, and we're going to basically just connect that to our debug node, which is here. And let's just say that the topic we're interested in is home /bathroom fan01, like so. Deploy that. So if I click that message and it's sent 1, we should get that message back that says that it's a-okay. So it should publish that message back there, which we've got in our code. And we've also got that birthing message as well. Let's check out if that's actually working. So if we go over to Node-RED, and let's see how we need to do this. Let's just add in /birthing message. So we should be subscribing to that, I think. Yep. So if I click that button there, right, so if I stop my code and then restart it, so Control-C, and then run it again, we should also see the birthing message. There we go. Birthing message fan1 ready. So that's the first message that gets sent there. We should also see when we press 1 there, not just that 1, but also the fan is a-okay message. I'm just not sure why that's not appearing on there. So let's go back in here. Oh, that's looking at the wrong topic, that's why. Let's go to home /bathroom. Get sick of typing this. Fan01. Let's save that, deploy. Right, so we click that. There we go. Fan is okay. So what's happening there is we're sending the 1 to that state topic, and then it's returning on the fan01 topic. Fan1 is okay. So that's defined in our status callback, where we basically just say the status message is device ID, which is fan01 is okay. So we can change that to is happy and okay. Let's stop that and restart. And if we go back over to our Node-RED, we can see there fan1 is ready, and if we press that, we can see it's happy and it's okay, which is down here. Cool. So that's how we can write some code in Python. We can write this as well in MicroPython using like an ESP32 or any kind of MicroPython device that has Wi-Fi. We could hook up a Raspberry Pi Pico to Wi-Fi using like a Wemos D1 Mini. And there is also, I was looking through one of the packs. I will do a proper deep dive on this one, wrong button there. What I was looking at from Citron, they sent me a whole box of goodies, and one of the things that they include in there is a Grove Wi-Fi connector. So it's essentially just an ESP8266, but with a nice Grove connector on the side. So if I grab this, so what we've got here is a I think that's an ESP12F, there we go. and then a nice Grove connector, so we can just connect that up, just pushing that in there, and then we can grab one of their maker kits, such as this one here. This is the Mqtt RP2040. It's a really great board. So this board here is got a Raspberry Pi RP2040 on board there, and it's got a whole load of Grove connectors, so we can connect that Grove connector into any of those ports like so, and if we flash MicroPython onto there, we can then use their code to connect to Wi-Fi. Now, one of the other cool things I saw with this when I was having a play around with it, is it this one, the Pico? One of them has a really cool feature. Yes, it's this one. Grab this. No, I just need to find that little chip. Right. So this is another board. This is their Mqtt Pi Pico, which has got a Raspberry Pi Pico in the middle, the usual kind of Grove connectors. It's also got a memory card slot reader there. And on the very other corner over here, there is some little ports there. Can you see there? It's got 8 ports, and it says an ESP01. I bought loads of these ESP01s right back when I started tinkering with Arduinos. And essentially what you do is you just push that into there, and that gives your Raspberry Pi Pico some Wi-Fi capability. And this is an 8266 as well, just really shrunken down. And those pins are really not breadboard friendly, but they are nice and friendly on here. So that's all it takes to provide a bit of Wi-Fi connectivity to your Raspberry Pi Pico. I'm not going to run any code on that now because we're kind of run out of time. We'll have a look at that next time. But it's not that difficult to run MicroPython, Wi-Fi, and then send messages like we've just done to an MQTT broker, and therefore make embedded devices, make things that connect to our networks and our home automation and things like our phones. We can do this remotely and then do all the things with automation. So let me just have a check and see if there's anything else we needed to cover off on our slides. I think we got through everything actually. So that was the MQTT. Yep, Finn. I've added this now at the end, so it's a bit more graceful. It doesn't just end keynote, which I always think looks a bit ugly on there. Cool. So that is everything I think I wanted to show you. So I'm going to look through the messages now. And this is the part of the video where if you're watching this on replay, I'll say thank you very much for watching, and I shall see you next time.